So what we like to see is a distribution that is a normal distribution. And many natural data sets actually will have that normal distribution. And because of that, we can use features about the normal distribution to analyze entire populations of data. And it makes things really easy for us, because think about that empirical rule of thumb, how we can say, well, we know this % of the data is going to be between these two markers. If we can be certain that we have a normal distribution, there are a lot of calculations that we can do using one formula and one set of analyses, and then we know exact numbers of what percentage of data is between two markers, or what the probability of getting a certain data measure is, and or a region of data measures. So we had that before, right? And you might be saying, well, what's different now? And what I'm telling you is that the empirical rule gives you a rule of thumb, and it's very generic and broad, and you just have to have kind of a mound-shaped distribution to use it. Here, if we're a little more specific and we have a little bit closer description of what that mound has to look like, and we can call it a normal distribution, has a bell curve, its total area is 1, the mean, median, and mode are all approximately equal. If it has all those characteristics, then we can get in between markers. So we don't have to just go 1 standard deviation away, we can go 1.3 standard deviations away. And we can find what % of our data is between markers then. So we get a lot more flexibility, but we have to be a lot more specific about our distribution to be able to do that. So we will use a z-score, because it will tell us how many standard deviations away from the mean we are for a particular piece of data. As long as we have a normal distribution, it'll tell us that. So what we do in words, it is z equals the data value minus the mean over the standard deviation. And if you learn that, data value minus mean over standard deviation, it's going to work whether you're looking at a population or a sample. But if you want symbols, the symbols are a little bit different. For a population, we put in mu and sigma, and for a sample, we put in x bar and s, because those are the sample statistics. Then also generally round your z-scores to the nearest hundredth, because that's what our table shows for z-scores, the table that we'll be using. So when you calculate a z-score, generally round it to the nearest hundredth. And we'll do some of these.